the basis of quantitative analysis, the cornerstone of inferential statistics, the ask, the myth, the question, the null hypothesis. Anyway, today we're gonna talk about the bane in all researchers' existence: how to get tenure. I'm sorry. That's not true. That's not true. We're not gonna talk about that. I'm fine with unemployment. I've come to terms with it. Anyway, we're gonna talk about statistics, stats. Yes, that's what we're gonna do. We're gonna tip our toes into it a little bit so we can slowly start tackling the abyss that is statistics. I'm sorry if I'm scaring you. I actually quite like stats. It's just a lot of people don't like them, and I do understand why. I see why. But you don't have to be scared of them. They can actually be quite manageable. So that's what we're gonna do here. We're gonna talk about it, talk it through, and we're gonna help each other to try and understand it so we can do everything we need to do nice and easy. So, oftentimes, we're gonna need to do quantitative analysis when we're researching into something. And why we need to do that? We need to do that because we don't really have the opportunity to get the entire population of whatever it is we're researching. So if we want to check, for example, if the average steel type Pokemon weights more than the average electric type Pokemon. Like, in order to do that without statistics, we would have to get the entire population of steel type Pokemon and electric type Pokemon in the world. Now, unless you're like delusional, like Team Rocket or something, you will understand that you pretty much cannot do that. That's not a possibility, which means that you will have to take a sample, just a few of steel type Pokemon and a few of electric type Pokemon, get an average from each and compare them. But in order to see if the difference that you find is not by chance, because you have a sample and it's very likely that it's just random, you do need to run statistics to see how likely it is to get the results that you actually got. I really hope that I'm making sense. Anyway, hopefully it will make more sense in a bit. So in this example of electric Pokemon versus steel type Pokemon, we need to have a theory that we test. Just to have everything nice and neat, we have a theory that we test, and that's what we get the stats on. So that's what the number is telling us. The number is telling us whether to confirm or reject that theory. And that theory is, in fact, a hypothesis. That's how we phrase it. And this is why we said the null hypothesis. So this is where it comes in, right? It's pretty much the cornerstone of inferential statistics, right? Where we need to come to a conclusion. So we have the null hypothesis. We have this statement that is being tested to see if it's true. But can we make any sort of statement we want for the null hypothesis? The answer is actually no. The null hypothesis, or H0, by the way, the null hypothesis needs to be a statement of homogeneity. It basically needs to state that wherever it is we're looking into, like whatever groups we're looking into, like the two groups in the example we brought up previously with the electric type and the steel type Pokemon, the null hypothesis says that there is no difference between those groups, that they're homogeneous, that their mean weight is the same. And that is the key for every study that we do. It needs to be this. It needs to be a statement of homogeneity. For example, if we're looking into what types of Pokemon are used more in VGC 12, for example. If we test it out by doing some random sampling with battles, then the null hypothesis would be that all types of Pokemon, water, steel, grass, electric, fairy, everything, all the types of Pokemon are used equally in VGC Series 12, so that there is no difference in usage frequency between the types. So that's what we would test. Another example, if we were looking into Pokemon natures and whether there's a difference between the observed frequency of certain natures between shiny Pokemon and regular Pokemon. And again, that the null hypothesis there would be that there is no difference in nature frequency in the different natures. So if 2% of shiny Pokemon are adamant, then 2% of non-shiny Pokemon would be adamant, for example. That's the null hypothesis. That's what we're going for. That's what we're trying to prove, essentially. But why is that? Why are we trying to prove statistically something that we're not actually trying to prove as researchers? Because if we have a theory in research, it's usually something that is it's different. It's something that for example, we do believe that there might be a difference in the natures of the different types of Pokemon, shiny and non-shiny. And I know all you data miners out there, you're gonna say that there is no difference. Okay, fine. Researchers are gonna research, okay? Just deal with it. Anyway, back to what I was saying. Why are we trying to prove something that is against, like, our natures as researchers? We're trying to prove that there is no difference between steel type and electric type Pokemon. But actually, when we started the study, we were trying to prove that there is a difference. But statistically, we need to prove the opposite. Why is that? And the answer is because sometimes researchers can get a bit carried away trying to prove something. So if we're trying to prove something, you might fall into confirmation bias. And this is really important. That's why statistics wants to penalize you a little bit by making you trying to prove something that is against what you're actually trying to do. So in our first example, steel type Pokemon, we have steel type Pokemon. We're trying to see if they're heavier than electric type Pokemon, if their mean weight is different. That would mean we would have to make the assumption that the two groups, steel type and electric types, they have the same mean weight, and that would be the null hypothesis. And the number that we would get, the p-value, which I want to talk about in a bit more detail in another video, because that's there's a lot to talk about that as well. The p-value would be a number that either confirms that the null hypothesis is valid, or would be a really, really small number. And how small, again, in another video I'll talk about in more detail, is we set it up. Usually it's lower than 0.05. Again, it's totally up to us. And so this very small value would mean that there is something different going on, and we would have to reject the null hypothesis. But if we reject it, what is actually going on? What is actually going on is the alternative hypothesis, which is the inverse of the null hypothesis, basically. So if you ever see H1 or H alpha or HA, I'm not sure if it's a Greek alphabet or Latin alphabet. Anyway, don't shoot me. If you ever see alternative hypothesis, bear in mind that it's just the inverse of the null hypothesis. So in our case, null hypothesis that both steel type and electric type Pokemon have the same mean weight. Alternative hypothesis would be that steel type and electric type Pokemon have a different mean weight. Hope it all makes sense. If you have any questions or you think it will be helpful, might be able to come up with some other resources with more examples. But anyways, that's it for now. Until next time, keep gaming, keep training, keep researching, and see you soon.